to bring Ranjan up now. I talked a little bit about what BC Hydro's been finding out in real life. Ranjan has been at BC Hydro for more than 20 years, and his job is to help business units get value from smart meters. And OMS is one of those ways, and he's interested and engaged in other ways as well. Ranjan, thanks very much for taking the time to share what you've been learning.
Thanks, Jesse. So as with most presentations, I'll give you a quick context around BC Hydro and our system. For those of you that don't know, we're on the western edge of Canada. We've got a population of roughly 4.5 million out of Canada's total 35 million. And you can see, based on the graphic I've put on there, as opposed to showing where we are in Canada, I tried to give some perspective on the scale of our service territory. You can read down the slide as to the size of our generation, transmission, and distribution system. We have a number of large generation plants in the north, but most of our load center is to the south along the border. And we border with Washington State around the south and with Alberta and Canada on the east. So I thought I would start with a bit of context as well around our smart metering program. That was really the foundation on which we're trying to build the integration with our OMS, as well as a number of other business initiatives. Obviously, the first component was upgrading our meters. Our entire province is approximately 1.9 electric customers, with the southern east corner having another utility providing service to about 100,000 customers. That was out of scope. We had to implement the telecom infrastructure for our mesh network. Our solution is from Itron, for those of you familiar with that. We implemented the head-end, the MDM system for collection of data, and a number of other systems that most utilities have had to go through. We also had to integrate with our existing BC Hydro applications. Forrest has mentioned our ESB, our service bus. We have a TIBCO product for that, and our technology team had not only the initial implementation work, but the ongoing upgrades as we move through the project, hot fixes and upgrades. We also have a theft detection solution, which may be somewhat unique to our particular initiative. From a technology perspective, the primary focus there is the transformer meters, as well as some energy analytics solutions for the large data sets and the analytics required for both revenue protection as well as distribution planning. We also have an in-home display substream, which is looking at getting devices to our customers for better use and understanding of their electrical consumption. That's been an ongoing technology as well as process and customer engagement project. We did explore new rate options from the perspective of can the technology support them going forward. We do not have a time of use rate nor any plans at this point, but we wanted to make sure that the infrastructure can support the sort of standard rates that we're seeing across the industry as we complete this technology implementation. As well, finally, we not only implemented the technology for our metering solution mesh, but augmented our utility telecom infrastructure with a number of initiatives, including a WiMAX install that our smart metering solution is starting to move over to in some areas. From a smart metering program perspective, there were three main areas of benefits that we identified in the early stages that we wanted to try and implement our integration as well as a process and technology to support. One was the avoidance of truck rolls to return to nested outages. So I believe most people on the call are probably familiar with the restoration process, whereby when power is restored, there may be small pockets of individual or groups of customers that have not had their power restored for some reason. Wanted to reduce travel to false outages. So I think this goes to some of the questions we've had already around when we do get information, we want to make sure that there is an actual utility problem that we need to go resolve. And if there isn't, then at least we need to know what other steps we can take. And finally, to improve the productivity of the outage and restoration notification from the meters for dispatchers as well as our call center representatives. So how do we use this information to improve the efficiency, the knowledge, and the potential actions that dispatchers for trouble calls can leverage, as well as our call agents, and what information and or decisions can they make with that information at their disposal. And so this information is from our business case, which is public on bchydro.com if anybody's interested in a little more detail on this or the broader program. So the next level down from our program benefits was really the objectives for our integration work. So how would we know when we're getting to the finish line around the work that we're trying to do around getting outage and restoration messages to the appropriate business stakeholders? So number one is we wanted reliable messages from smart meters. And reliable could probably be translated into we understood the process and the technology and what we will and won't get in what situations. Given the nature of the network, I think some of the questions have already come up around how reliable are those messages and what do you do when they don't appear. Second bullet is around pinging and load side voltage. So the first bullet was more of the reactive, passive, I should call it, information that we're getting from the meters. We're waiting for that information and we'll react. The second one is more proactive in terms of if we have some information, how do we validate that? What is the status of the devices we're checking? And as Forrest mentioned already, all that needs to come together with business processes. And in fact, we need to be clear on what processes we're going to drive and where those benefits can be realized before we start gluing too much of the technology together. So this slide here is more of a reference slide. And what Forrest already sort of broached in his section was what is we'll call it the life cycle of an outage. And there's some representative durations there. Those are by no means facts for us to anchor to, but more to show the relative size from a utility broad perspective. And it's a fairly logical sequence. When the power goes out, it takes a while for the utility to be notified. Then we have to determine the cause, dispatch the appropriate crew. The crew has to get there, repair it, and then we need to make sure that we've repaired it appropriately and that the power has been restored. So from an SMI smart metering perspective, we started to look at, well, which areas can we influence here? And I think the obvious one is really in the early duration of an outage, meaning we can augment the notification of the utility by using the smart metering events and exceptions that are kicked off from a meter when the power fails. In our case, we did initial integration, and we realized pretty quick that there's a lot of data that comes in, and the classic turning that into information is always going to be a challenge, and we need to have constant pressure on that. So for the interim, that's not replacing customer calls, it's augmenting that information. The one thing you'll notice on here probably is that we don't have the customer experience layered on here. This is primarily from a field operations restoration process perspective, and that was really the focus of our initial integration work. It was technology and process integration primarily at our dispatch and restoration center. But as we start to look at, well, what are the broader implications of smart metering data? How do we use that data? What other processes and organizations are impacted? We were looking at how do we layer in not only the customer experience from a customer services organization, but even from the field crews who are really the front line that are in meeting with the customers while they're out there. What information do they need, would they want, that would augment their services without necessarily detracting them? So with that previous landscape, started to look as well as, in addition to what can SMI influence, what other work from a typical utility perspective and from BC Hydro's perspective can we leverage against those timeframes? So as I mentioned before, smart metering, we can look at the initial point. How do we augment and improve the efficiency of the utility getting notified of an outage, as well as we can use the interactive communications with the meter to validate that it's actually been restored. But there's a number of other technologies that we probably won't get into too much detail today, but that are definitely focuses of area going forward, which is how do we maintain, if not improve, our integration with SCADA and other DA devices to get that information into our system of engagement for the dispatchers, meaning our Power On OMS system. And how does that augment the smart metering data? Does it contradict it in certain cases? Does it augment it? Does it create more confusion? We need to understand that before it gets too far into the actual frontline workers' perspective. And of course, work management. That's really the focal area in the middle. We haven't looked too deeply into the actual core data from SMI, smart metering, and how it can augment that. But it goes to the previous question, I believe, around geographically displaying meter status and communication status and history. If that information is available, then there's perhaps ways to more efficiently distribute work, either in the office before it goes out, or for the field while they're out there. So with all that, we started our initial integration with our smart metering data and our outage management system, which is by GE Power On, a little over a year ago. And that was really to test the integration from a technology perspective and make sure we can get the information flowing, and to get an initial view into how both our OMS system works and the actual behavior of the event. So going in, we had done probably what most utilities would do. We've talked to other utilities. We attended webinars such as this to understand what should we expect, what kind of assumptions do we have either formally or informally going in. And so these were kind of the highlights, I think, from looking back in time, was that really we would get a power outage notification and a restoration for pretty much all meters. When the power goes down, given the network coverage that we're supposed to have with our meters, given the behavior, given what we understood from other utilities, there should be a pretty high return rate on those event messages. We would also be able to leverage them pretty immediately, almost right away, to improve efficiencies from our dispatch or customer care perspective. And what that probably translates more into is that the interpretation and the process work we probably diminished a bit in terms of assuming that it's really only two types of information, PON, PRN, and should be straightforward to present to the frontline workers to understand what their next steps would be. Third one, and I think this came up earlier, was we'd be able to dispatch before a customer even called. So I think there again, it comes into something we've learned along the way, which is the PON and PRN is very useful, and it really tells us the state of the meter. It doesn't necessarily translate into the state of the distribution system or the transformer or the other electrical equipment in that area. It really is a meter event, a meter exception. So we need to take extra steps, and it kind of goes to the previous step around what extra validation, verification do we need to do before we take action. The actual integration with our OMS was relatively straightforward. It's more a matter of, further to the previous questions, around what do you do in certain scenarios with PON and power outage notifications and power restoration notifications when they come in different time sequences. You get repeated ones. You get one for some meters but not other meters. How do you address that? But we assume that that should be relatively straightforward. If we're getting all the PONs and PRNs for our meters, then the integration work should be relatively straightforward. And the last one is really, okay, this is great. When we get all this information, when we have large storms, which we do in the Pacific Northwest, and there's large-scale outages, in addition to the reactive messages, we can use that proactive meter communications to validate scope, scale, nested outage restoration confirmation, all that at a large scale and fairly easily, not only for our dispatchers, but for other field crews and managers as well. So with those assumptions, we moved full speed ahead into, let's start implementing this solution and see where we can go. And this is where we engage Bridge to help us sort of plan out a bit of roadmap for this particular initiative and help us identify some of the solutions and logic that we might want to try and apply.